tree diagram for this one involves getting an 8 or not getting an 8. We have a 1 in 8 chances of getting it, and we have a 7 in 8 chances of not getting an 8. If we don't get an 8, we try for an 8 or not an 8 again. So the tree diagram would continue as such, etc. What's using a tree diagram, explain why the probability of the game ending before the 4th roll, so that's 1, 2, 3 rolls to here. If the game ends on the 4th roll, we're too far, so we actually just need to add the chances of it happening on the 1st, on the 2nd, or the 3rd roll. Now on the 1st roll is 1 on 8, on the 2nd roll it will be 7 on 8 times 1 on 8, and we add it to the 3rd roll, which would be 7 on 8 squared plus times 1 on 8. I don't know why I said that. Which is exactly what they said there. What is the smallest value of n for which the probability of the game ending before the nth roll is more than 3 on 4? So this is ending before the 4th roll, p before 4. So to find the probability of before n rolls, we just have to continue this, and guess what? It's another series. There's a lot of series in this paper. So at 4 there are 3 terms to the series, so the probability of before n, there would be n minus 1 terms in the series. It's a geometric series because we have to times by something to get to the next term. A in the series is 1 on 8, R is 7 on 8. So I would actually have 3 terms, so it would be A R to the 3 minus 1, n minus 1 because I'm going for n terms here, on R minus 1, which would be 1 on 8 by 7 on 8 to the n minus 1 on 7 on 8, so that's 1 on 8 again on the bottom there. If I go R minus 1, actually negative. So it will be, simplify again, if I pull my negative out the front, I can cancel my 1 on 8s, so I'll actually have 1 minus 7 on 8 to the power of n minus 1. Now we wanted it to be, it was more than 3 on 4, so 3 on 4, we're basically going to solve this for n. I'm going to add this to that side, subtract that from that side, and say 7 on 8 to the n minus 1 has to equal 1 quarter, because that's 1 minus 3 quarters. And because that's an n that I want here, I'm going to drop a log both sides because that's going to help me bring my power down. So if I drop a log in both sides, that's a legal logarithm move. I then have a possum up here which can come out the front, so n minus 1 times ln 7 on 8 equals ln 1 on 4. So bracket that, n minus 1 equals logarithm of a quarter on the logarithm of 7 on 8. Run out of room. N minus 1 equals ln 0.5 straight in the calculator divided by ln 7 on 8. 5.1. So n would have to equal 6.1. So that's how many rolls I'm going to need. The smallest value of n for which the probability ending before that is more than 3 on 4. The probability of it ending being more than that means I'd have to increase my n by 1, so n up, not by 1, I guess, go up to the next n rather than back to the previous n. So when n is 7, my probability will increase to being more than 3 on 4. Always think through that logic carefully.